So quick review at the top. What's log 10? It is 1. What is log 100? 2. What's log 1,000? 3. Okay, it's very easy. Okay, very easy. And let's get things rolling. Now, there's a reason why I ask you to, just knowing these 3 values, because we have a little bit of an exploration and a little bit of a puzzle for you to solve. So here we have 2 puzzles. Okay, so let's look at puzzle number 1 right here. Now we have log 1,000 on the left, and on the right, I'm changing the way to write down the number 1,000. I'm writing the 1,000 as 100 times 10. I hope you're okay with me writing 100 times 10 in place of 1,000. The challenge is this. There's a little box right here. I'm not sure if it's printed very well on your paper. There's a little box right here. And your challenge is to decide whether to put a plus, minus, multiply, or divide into this little box to maintain a true statement. It'll be a plus. Why? Because you know what log 100 is, right? What log 100 is? 2. Log 10 is 1. And we knew what log 1,000 is. Log 1,000 is 3, right? So the only way that's reasonable to put 2 and 1 together and get you to number 3 must be a plus. Does that make sense? Why it's a plus? Okay, because some people, when they see this, they were like, oh, see, there's a multiplication right here. So they would just think about multiplication. But I would say, well, look at the numbers. You know the numbers. Let's make sure that that it becomes a true statement. And take a look at puzzle number 2 on the right. So we have log 100 on the left. So the way I write the log 100 is 1,000 over 10 on the right-hand side. So now, same question. There's a little box right here. What would you put inside the box? Plus, minus, multiply, divide. It must be a minus. Because 3 minus 1 equals to 2. Now, so I hope these 2 puzzles are not too difficult or too challenging to you. The reason why I'm putting these 2 puzzles on this page is because of this reason. I remember when I was a kid, my teacher showed me these 2 properties and said, all right, go ahead, memorize these properties. We'll do some practices and then just know them very well, these 2 properties. Did I know why these properties are true? I had no idea. And because of that reason, there were lots of misconceptions, on these log properties. And so when I was growing up, and I was like, no, there must be some kind of justification. And this is how I learned to use simple numbers, like these simple numbers, to validate these properties. I want you to imagine that you are trying to exercise these properties, and somebody just come to you and say, hey, how do you know this is true? And you would go ahead and show the person who challenges you that, well, simply look at these examples. And you can prove them. You can prove the validity of these properties with these examples up top. Okay, so again, let's take a look at these properties. If you have a log of 2 things multiplying together, it becomes 2 logs that are added together. If you have a log of 2 things dividing each other, it becomes 2 logs of 2 logs subtracting each other. And now, I also want to make sure that you understand why we're doing this, because I Well, I just did it when I was in high school. And then I went to college, I went to calculus, and then in calculus, I realized something. Now, again, it's calculus. So we're not going to see it until a year and a half later, but I want you to see it. In calculus, it turns out that we do not like things that chunky, so clustered. We don't like a lot of things multiplying together. We do not like a lot of things being divided with each other. So we want things that are more individualized. And how can we make that happen? By having logs, we can break it down into smaller terms. So that's what you will see in calculus if you're taking it. Okay. Just want to give you a little, I'm just planting a little seed so that you know, all right, one good thing about logs is that you can break it down to smaller terms. So now let's go ahead and take a look at these examples.